Hello, Pre-Calc students. So we are on the second day of 12.1, so you should have the 12.1 notes out again. We did the front side of it, and now we're going to go to the back. So we're going to start looking at some Venn diagrams. So A union B, union is also kind of like OR. I'm sure you kind of remember ORs and ANDs when you did like inequalities and things. So A union B. All right, so here we have a rectangle. In this rectangle is going to be U, the universal set. When it's A or B, what's going to happen is they'll probably have some stuff in common. All right, so you've got them kind of overlapping. I'm sure you've seen Venn diagrams before. And when it's A or B, that means that anything that's part of A or anything that's part of B or part of both A and B, any of that will be part of the solution. So I'm shading in this whole thing. This is A intersect B. All right, this is known as kind of like and. So it's what do they have in common? So if this rectangle represents the universal set, and we have A and B, once again, kind of overlapping, what do they have in common would just be this section in the middle. All right, because that's the only place where they overlap. That's the only thing they're going to have in common. This, remember that lovely symbol means that A is a subset of B. All right, so anything from A is part of B. So once again, we've got our universal set. A, so if this is A, all of it basically will be part of B. Anything that's in A will also be in B. So one way to draw it would look something like this. All of A is contained within B. This one, remember, this is the complement of A, or basically not A. So it's everything that's part of the universal but not A. So if A is here, the complement of A is going to be everything that's part of the universal but not in A. So it's basically going to be everything but what's inside the circle. All right, so it's going to be everywhere out here. That's the complement of A. If you have something like this where A intersect B is, like the null set, this means that they have nothing in common. All right, there is nothing that they both contain. Nothing in common. So when you draw this out, you've got your universal set, and they have nothing in common, which means that they don't overlap at all. So you've got A over here and B over here, and they're kind of just separated. Okay, counting formula. All right, if A and B are finite sets, then, so here's a lovely formula that will be helpful in some problems when you are counting. All right, this formula says if you're trying to find the number of things that are in A union B, you're going to take the number of items that are in A, add the number of items in B, and then subtract off the intersection of A and B. What happens is you don't want to have duplicates. Like kind of when we did these numbers on the other side and we were finding out how many things were in A union B, technically we had a 4 that overlap, but we didn't list 4 twice. So we're kind of subtracting off any of the duplicates that they have in common. So that's part of the counting formula, and we'll use that down below in example 5. Then there's the addition principle of counting. If two sets A and B have no elements in common, that is, if the intersection of A and B is the null set, then the number of A union B will have to be however much is in A plus however much is in B. You don't have to worry about subtracting off the intersection because there is nothing in common for their intersection. So you just add however much is in A, add however much, and add that to however much is in B, and you've got your answer. In general, if n sets, A1, A2, all the way to AN have no elements in common, then the number of A union B will be the number of A1 plus A2 plus the number of A sub n, etc. So if there's no overlaps at all, when you take the union of these sets, you're just basically finding out how much is in A1, how much is in A2, and adding them all together. So let's look at example 4. Okay, example 4 is going to deal with the Venn diagram. Example 5 will use that lovely formula, the counting formula, once we do it a different way. So we've got a survey of 60 business freshman business students at U of I produced the following results. So 19 of the students read Business Week, 18 read Wall Street, 50 read Fortune, 13 read Business Week and the Wall Street Journal, 11 read the Wall Street Journal and Fortune, 13 read Business Week and Fortune, and 9 read all three. And then we get to answer these questions. So what you want to do is you want to create a Venn diagram, and this is going to be kind of like a nice little puzzle. So the main things we're talking about are Business Week, Wall Street Journal, and Fortune. Those are the three main publications. So what I'm going to do is I'm going to create 3 bubbles here. Let me draw them a little bit better. I have a little more overlap than that. Yeah, something like that, and something like that. Not the best circles, but you get the idea. So BW would be Business Week, Wall Street Journal, and then Fortune. All right. And what you want to do is you want to work your way from the inside out. All right. So we know that 9 read all 3. Okay. So the only place where all 3 overlap is in here. So we're going to put a 9 right here. All right. So 9 read all 3. Then let's see, we know that Business Week, there's 19 total students. We're going to eventually erase this, but I'm just going to kind of put it off to the side. We know that 18 students altogether read Wall Street Journal and 50 students read Fortune. All right. We'll eventually erase those because those aren't going to be needed, but we know that all together in this Business Week circle, there should be a total of 19, and how much should be in Wall Street Journal. So let's see what we got. 9 read all 3. We did that. 13 read Business Week and Fortune. So Business Week and Fortune would end up being in this section here. And we know there's 13. Well, if we already have 9 here, that means there's going to have to be 4 here. All right, there's 13 altogether. So we've got that situated. 11 read Wall Street Journal and Fortune. Well, if we look at that piece, all right, Wall Street Journal and Fortune is this section here that I'm kind of highlighting in green. And if that's 11 and we already have 9 here, that means that 2 have to go here. And then we have 13 read Business Week and Wall Street Journal. Well, that's going to be this section in here. We've got 9, so this piece is going to have to be 4 because altogether that's going to be 13. All right, and then from there we should be able to kind of fill in the rest. We know that there's 19 that read the Business Week. So if you add 4 plus 4 plus 9, you're going to get 17. Subtract that from 19, this is going to be 2. For Wall Street Journal, we know there's 18. You've got 9 plus 4, 13, 14, 15 total. So this is going to be 3. And then Fortune's the big one. We've got, 13, 14, 15 so far for Fortune, which leaves 35 for the rest. And so now we've kind of filled in our Venn diagram. All right, so then let's see. And we knew this again was a survey of 60 freshmen. What's going to happen next is how many students read none of the publications? Well, let's see. What we're going to need to do is figure out how many total numbers we have here, because we do need to keep in mind that we have overlap. So what we're going to need to do is add 35 plus 2 plus 4 plus 9 plus 4 plus 2 plus 3 to see how many total people are reading one of these 3 or all of these 3 or some of these 3. So if you add 35 plus 9 plus 2 plus 4 plus 4 plus 2 plus 3, if you add all of those together and you do that, you're going to get 59. All right. And we know there was 60 freshmen total at U of I. So if you do 60 minus 59, there's only going to be 1 student who's not reading any of these publications. So the answer for that is 1. Then we've got how many read only Fortune. So only Fortune means that it's not part of an overlap at all. So it's just going to be this number out here, which would be 35. And then how many read Business Week and the Wall Street Journal, but not Fortune? Okay, so Business Week and Wall Street Journal. All right, but not Fortune. So we got to look where Business Week and Wall Street Journal overlap, but not including Fortune. So it's going to be this middle number right here, which is going to be 4. All right. So that's kind of how the Venn diagram stuff goes. We'll do more with the Venn diagrams tomorrow, actually. Okay, last example is a pair of dice is thrown. In how many ways can the dice show doubles or a sum over 7? All right, we're going to eventually use the counting formula up above, but let's just go through the possibilities for throwing a dice. Dice means you have 2 of them, so you could get like a 1 with a 1. You could get a 1 with a 2. We're going to just do all these possibilities. 1 with a 3, 1 with a 4, 1 with a 5, and 1 with a 6. You could get a 2 with a 1, a 2 with a 2, a 2 with a 3, a 2 on the first dice, 4 on the second dice, 2 with a 5, 2 with the 6. You could do 3 with a 1, 3 with a 2, 3 with a 3, 3 with a 4, 3 with a 5, 3 with a 6. Tedious. It's 4 with a 1, 4 with a 2, 4 with a 3, 4 with a 4, 4 with a 5, or 4 with a 6. You could get a 5 on the first dice and a 1 on the second. 5 with a 2, 5 with a 3, 5 with a 4, 5 with a 5, 5 with a 6. And then 6 with a 1, 6 with a 2, 6 with a 3, 6 with a 4, 6 with a 5, 6 with a 6. All right, so those are all the possible outcomes. Now what we want to do is we want to figure out how many possible ways we can get doubles or a sum over 7. Okay, so as far as doubles go, we've got the 1s, the 2s, the 3s, the 4s, the 5s, and the 6s. And then sum over 7, so not 7, but more, would start here at 2 plus 6. And let's see, 3 plus 5, 3 plus 6, 4 plus 5, 4 plus 6, 4 plus 4 would also be part of that. We're going to have 5 plus 3, 5 plus 4, 5 plus 5, 5 plus 6. More than 7. So 6 plus 2, 6 plus 3, 6 plus 4, 6 plus 5, and 6 plus 6. And then you can kind of count those all together, and you can figure out the answer. Or the other possibility is you can use this lovely formula. So I'm going to show you how this works. So what we're doing is we're doing the number of doubles union a sum that's greater than 7. Okay, and if we follow that formula, it's going to equal the number of doubles plus the number of those that are a sum greater than 7. Let me zoom out so I can fit this better. Minus, oh, that's really small, minus the number of doubles intersected with a sum greater than 7. Okay, so you can see the formula up here. All right, we're doing the number in the first set plus the number in the second set minus the intersection of those two sets. All right, and if you kind of look at this picture to kind of help you, the number of doubles, we've got 1, 2, 3, 4, 5, 6. All right, so that's going to be 6. Then you have the number of the sum that's greater than 7. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, and then we're going to get rid of any of the duplicates because again, some of those that were greater than 7 also were doubles. So we want to get rid of the duplicates. And so we want to see which ones are both doubles and a sum greater than 7. So doubles and greater than 7 would be the 4 and the 4, the 5 and the 5, and the 6 and the 6. So there's 3 of those that are not only doubles but greater than 7 when you add them. So we're going to subtract those 3 off. And if you were to count all these red circles, you would get 18. All right, and so that will come in handy when you do some homework later on. All right, so hopefully that makes sense. What you're going to be doing now is kind of finishing off the day 1 homework. So I had assigned 1 to 21 odd. What you're going to do now is the page 881. You're going to do 2 to 20 even, and then you're also going to do 31 to 38 all. All right, so that's going to be the assignment for this evening, and then I'll probably do a Google Meet on Friday so that you can kind of check in and see if you have any questions on this 12-1 stuff. All right, good luck with your homework. Thanks.